In this lesson, we are going to find the inverse and compare them with their domain and range. So here, remember, function is an ordered pair, set of ordered pairs such that any value of x has exactly one value of y, and the inverse is a relation and its inverse whenever both relations are functions. And if you remember the inverse from algebra 2, if you're given a relation like the one we have here, all we need to do is to take the points, switch x and y, and this is the inverse. So this is the original function and this is the inverse function, inverse relation. So here, let's go. Whenever we have a graph and its inverse, it's simply a reflection across the line y is equals to x. And what you see here you have negative 3, 0, and see this is the same point, which is 0, negative 3. You just take the points given, and then you switch x and y, and you get the new points right there. Okay, and these are the steps. Step 1, replace f of x with y, switch x and y, so for y, and then you use the notation for the inverse. Let's do some examples. So step 1, remember, is to, let's start by writing the domain. See, this is a line, so the domain is going to be negative infinity to infinity of the original. Now we're going to find the domain, we're going to find the inverse. So this is 4x plus 8. So I switch x, I replace f of x, so it's going to be y is equals to 4x plus 8. Next step, I'm going to just solve for y, so subtract 8 from both sides. Then I'm going to divide everything by 4. So I subtracted 8 from both sides. Did I switch x and y? Let me just go back. Let me back up to my steps right here. So 4x plus 8. So this is y is equals to 4x plus 8. Let's now switch x and y. Now I'm going to subtract 8 from both sides. So I get x minus 8 equals to 4y. Then I'm going to divide by 4, everything by 4. So what do I get? I get y is equals to x over 4 minus 2. And see, this is still a line, and now I can use the notation for the inverse. So x over 4 minus 2, and here, so that's x. So the domain here is just going to be negative infinity to infinity because it's just a line. So this is the inverse and that's the domain. Okay, and let me highlight the inverse and the domain. Okay, now let's go to the next one. So here, this is the function I have. So step 1, I'm going to write y is equals to half x squared plus 1. I'm now going to switch x and y. I'm now going to solve for y, so I subtract 1 from both sides. And now I'm going to multiply by 2 both sides to get rid of, I'm going to multiply everything by 2. I'm going to multiply by 2 over there. So I get 2x minus 1 equals to y squared. And I could simplify this is the same as 2x minus 2 is equals to y squared. So then y is going to be plus or minus, I get a square root. To undo square, you get a square root, 2x minus 2. If you graph this function, you're going to get, because it's plus or minus, so you're going to get this function. And this is going to be the domain. See, this is going to be the domain. So you can see x is greater than 1. And you can see the range is all real numbers. But see, this is not a function because it does not pass the horizontal line test. Not the horizontal, but the vertical line test. It doesn't pass that test. So it means we cannot have the plus or minus. So the inverse can only be just, so we take this out. So the inverse is just going to be the positive part. So which is going to be 2x minus 2. And this is the one shown here in red. And we can write the domain for that. So it starts at 1 included, to infinity. And the range starts from 0. And let's just focus on the domain at this moment. So this is the domain. But we can also write the range. So that's the domain. And the range is going to be from 0 to infinity. Okay. And here, let's move on. And the next, find the inverse. How do we find the inverse of this one? Remember here, the domain cannot be 1. X cannot be 1. So let's find the inverse. So it's going to be all real numbers except 1. So I'll just leave it like that. And then you can write it in interval notation. So let's find the inverse. 2x over x minus 1. I switch x and y. So, and you can see we have y in 2 places here, x in 2 places. So this is going to be x is equals to 2y over y minus 1. Then I need to get rid of this fraction, so I'm going to multiply by y minus 1, and so I get x y minus x is equals to 2y. Then let's put the y on one side, so xy minus 2y. And let's add x to both sides. Then I'm going to factor the y out because the goal is to isolate y. So x minus 2 equals to x. So y is equals to x over x minus 2. And you can see here, so this is the domain. And so not the domain but the inverse, and you can see x cannot equal to 2. That's the domain of the inverse. And now here we can use composition to verify the inverses. So here, remember to, if two functions are inverses of each other, f of g of x is the same as g of f of x. Let's look at an example here. So I need to find f of g of x. And what does that mean? I'm going to take the f function, and where there is x, I'll plug in g of x. So let me use a different color here. Where there is x, I plug in g of x. So this is half x minus 2. Then I just need to simplify that. So this will be 2 over 2x minus 4 plus 4. And this is equal to x. And then we do g of f of x. So I take the g function, so 1 over 2, instead of x, I'm going to put f of x. So I'm going to put 2x plus 4. Then I just need to distribute. So when I distribute, I get x. 4 over 2 is 2 minus plus 2 minus 2, and I get x. And if you get x, and here we can say f of g of x is equals to x, and this is the same as g of f of x, and that means they are inverses of each other. So inverses of each other. Another example here. Let's start by finding f of g of x. And this just means I take the f function, and instead of x, I'm going to plug in 4x minus 8 plus 8, and that means I get 4x over 4 minus 8 over 4 plus 8, and what do I get? So x minus 4 plus 8, which is x plus 4. Okay, let me do the next one. G of f of x. So I take the g function, and instead of x, I'm going to plug in 1 over 4x plus 8, and then minus 8. So this becomes x plus 32 minus 8. So x plus 24. And since I did not get x in both cases, so I can just write f of g of x is not the same as g of f of x, and it's not equal to x, so not inverses of each other.